Hello friends, this question is from the part test 1. Subject name is network theory, topic name is network solution methodology. It's a 2 marks problem. In the question we have one network which contains a current source of 6 ampere value, and question says that calculate the Thevenin voltage and resistor across the point A and B. We need to simply calculate the VTH and RTH across A and B. Okay, so first of all calculate the value of VTH. So VTH is what? VTH is known as the Thevenin voltage. VTH is basically open circuit voltage, right? Across the point you need to calculate. So A and B are already open circuited. Fine. So in that case, like question is then easier for you because the A and B are already open circuited. So what you need to do? You need to find the voltage difference between A and B. So what you should do? What is the voltage difference? I mean, the name itself suggests voltage difference is a difference of two voltages, right? So basically voltage difference between A B is basically difference of voltages VA minus VB. Okay, here I am assuming that VA is greater than VB. It could be VB minus VA also, but the bottom line is this: the voltage is a difference of potentials at two different points, right? So what you need to do, find out the potential at point A, calculate the potential at point B, and subtract it. So it's a very simple problem. We already have a current source. Apply a current divider here. Just name this terminal A and B. Let's apply a current divider here. Name this current in the branches I1 and I2. So what is the value of I1? I1 will be what is the current divider? Current divider is the total current, which is 6 here, upon the current of the other resistance of the other terminal, which is this 6 plus 4. 6 plus 4 upon total resistance. How many resistance we have? 1 plus 4 plus 6 plus 4. So it is like 60 by 15, which is 4 ampere, right? Similarly I2, again current divider, very simple problem. Total current into, now I2 is the current across this terminal, 4 ohm and 6 ohm. So I2 is total current 6 into resistance of other branch, which is 4 plus 5. 4 plus 1 5, again 1 plus 4 plus 6 plus 4, so it is like 30 upon 15, which is 2 ampere. So now we have I1, we have I2. What is the VA? VA will be potential across 4 ohm. What is VB? VB will be potential across 6 ohm. Let's calculate VA. V will be VA minus VB. What is VA? VA is the potential across 4 ohm, which is your 4 I1. What is VB? VB is the potential across 6 ohm, which is 6 I2, right? So just write it down here. 4 I1 minus 6 I2. You already calculated the value of I1, which is 4 ampere. So like 4 into 4 minus 6 I2, you already know it is 2 ampere. 6 into 2, 16 minus 12, which is 4 volt. So VAB, which is in this case is my VTH, or also known as open circuit voltage, 4 volt. So VTH is the 4 volt. Next is the RTH. Now you need to calculate R equivalent across A and B. How can you calculate R equivalent? For the calculation of the R equivalent, rules are simple. Thevenin theorem says that for the calculation of the R equivalent, always open circuit the current source, and calculate the R equivalent across the point. So open circuit the current source. We will have a network as the current source is open. So we will have 1 ohm, 4 ohm, 4 ohm, 6 ohm, and you need to calculate the resistance across A and B. The calculation of the resistance is always very simple. Assume one battery here and see the current flow. If current is dividing, it's in parallel. If current is series, if current is not dividing, it's in series. So I1 and I2 current will divide at this node, and then we're going to sum up again here. So this 1 ohm and this 4 ohm, they are in series, and this 4 ohm and this 6 ohm, they are in series, and these two components are in parallel. So 4 plus 1 is in parallel with 6 plus 4, which means 5 in parallel with 10, which means that your resistance is 10 by 3 ohms. So your RTH is 10 by 3 ohm. So we have calculated both the values. RTH is equal to 10 by 3 ohms. VTH we have calculated as 4 volt. Right? It's a problem of Thevenin's theorem. It's a very simple problem, but the topic itself is very important. Thevenin's theorems are very important, okay, because they have a very distinct weightage. Every year you can expect 1 to 2 problems on this topic, and the theorem itself, Thevenin's theorem, is a very important topic. I mean, in theorems we have a three very important topic. One is Thevenin's plus maximum power and plus superposition. Okay, so although all entire topic is important, but 80% possibility is that you will get a problem, or you can say the 90% possibility is that you will get a problem of either of these three topics. So it's a very important topic. Please prepare it well. Thank you.